So first slide is going to be hopefully something pretty familiar to you all. And so what I'm going to sort of do here is just sort of talk about how we at TTW try and approach this from a designer's lens, and explain the logic that we try and pass through our projects. So I guess historically in Australia and around the world, a lot of the effort around carbon reduction in buildings has gone into the sort of operational component of it, so the usage part of building structures, of buildings. And really that's been done in large part because of the type of energy that's being utilised, and the low-hanging fruit that is, reducing the operational component of buildings. Where my business comes into play is much more in the A1 to A3, which is that production. So what's the embodied carbon component, and to a lesser extent, the construction aspect as well. So how we actually piece together our structures. So today we'll discuss a lot of the strategies around the A1 to A3 space, but I really think as an industry, we need to start thinking more seriously around the world of circularity and some of the opportunities that the industry has over in Part D. And we'll talk a little bit about why that is as we go through. So to just frame the challenge and put the spotlight on structural engineering, buildings are accounting for around 28% of the global greenhouse gas emissions. If you think about a building as it stood in 2019, about 84% of that energy was related to the operational carbon, and only 16% was actually tying through into the embodied portion. And then of that component, 12.5% was actually the constituent materials that make up the building. So it's not a hugely significant part, so it makes sense why we have energy efficient fridges and insulated buildings and things, just to try and improve that operational component. But we fast forward to 2050, we have this amazing green energy efficient grid, and all of a sudden the tables turn. And so the embodied carbon proportion of buildings is sort of projected to be 85% of the portion of the building's total greenhouse emission, and then within that embodied portion, then 78% is actually related to the that production usage stage. And so if I drill a little bit further into that and shine a lens on what TTW does as structure and facade designers, you can see 2019 terms, the structure's only contributing around 8% of that total emission. So, we're roughly 65% of the total production phase sits in structure. But as we launch into 2050, about half of the total carbon is related to structure, and of that production phase, it's sort of, 65% again. So there's going to become an increasing demand on us as designers and engineers to try and address that component. And, we're already starting to see a lot of work around the certification schemes are starting to adapt to push towards, monitoring embodied carbon in addition to the operational components that they've done for the sort of last 10, 15 years. So to jump into the timber space, because not all of the approaches are created equal. I thought this graph, which I've borrowed from the iStruct, is a particularly useful one. So now let's forget about the concrete and composite things. They're sort of muddying the water. But if we start by looking at timber 1, and we start at 0 years, so we see this initial expenditure of embodied carbon that's associated with the harvesting, the construction, the manufacturing process of the material. Things that can also impact that, where the power is sourced from, types of machinery that are utilised and the efficiency of that. Once the material is actually made, you then start to move through into that sort of usage period of the building over the next 50 years. Now, if in a normal scenario, that timber is hopefully sourced from a sustainable plantation, and the timber that's chopped down is replanted, and so that there's a sort of an ongoing extent of absorption that occurs until the next harvest. Now, at the end of the project cycle, the building's finished, it's demolished, and more often than not, that carbon is then released back into the atmosphere, which accounts for that spike you see at the end. You can see the difference on the worst case scenario. If the timber is not sustainably sourced, it can have a pretty significant impact into the overall carbon within the structure. And then right down the very bottom, that sort of best case scenario is obviously it follows the same pathway as a typical scenario, but there's a preservation, or there's a post-usage scenario for that timber to continue to sort of actually lock in the carbon benefit that it has. So it could be reutilized in another building, it could be deployed in another form, but it's not released back into the atmosphere, and so that's something that is not utilized a great deal at the moment, but I think as circularity becomes more critical, it's something that's going to get a lot more airtime. So just to touch on some how these themes then compare to various structural systems, this is something we use to try and just show the criticality of pulling a few levers around timber and also around concrete. So this is standard timber, this is normal Portland cement concrete, nothing special, and Australian procured steel in this graph. So what you can see is that if you're not sequestering any carbon in your timber, the level of performance is not hugely dissimilar to concrete. It's slightly better, but not markedly. If we change out the Portland cement and concrete, the concrete, and we do that for GGBS or fly ash, then that level of performance in the concrete actually starts to hop above timber without any type of sequestration, and so it's an important thing to point out, particularly around the timber and the sourcing of it. But then finally, you can see this one, and this is where timber becomes a very compelling point, is where you are actually able to sequester that timber, sequester the carbon within the timber, and then it becomes a really compelling argument from an embodied carbon standpoint to utilize this material over the greenest of concrete you have or structural steel. Now, this is actually one of my sort of very valuable slides we have as designers, because sustainable design sometimes has connotations as, people pay a premium for something to be sustainable. And we really think at TTW that good design should be sustainable design. So rather than paying a premium for something to be sustainable, there's a whole lot of other levers that we have as designers that we can pull in order to actually achieve lower embodied carbon designs. And it starts with some of those really initial decisions that happen within a project. So the sort of first thing we really try and do is actually, well, let's set a bit of a benchmark and a target for the project that we're going to work through. So what would be a standard way of trying to solve this problem? Let's make it a realistic target rather than one that we're always going to measure well against. I think we need to challenge ourselves as an industry. And once we've done that, then we can actually start to sort of, challenge some of those original design parameters. So, building shape and forming, how podiums and envelopes are actually formed have a huge impact on the efficiency of building structures. And so there's savings that we can glean regardless of material selection or grid from that step. The next portion is the building performance, and this is something that is traditionally overspecified. So if you think about commercial floors, there's a lot of performance requirements which are never really utilized in a building, and it's a lot of times it's driven around tenant choice, but so they're comparing two things that they don't necessarily need. So there's a potential education piece where we could reduce the amount of super dead load, for example, or relax the vibration requirements on a building, or potentially we could look to increase the design life if it was a bigger structure. All of these things, again, have great impacts around the sustainable aspect of the building. Once we've done those first few things, then maybe we start to think about what we build the building out of. And I think the material selection needs to respond to those other components rather than necessarily just jumping to an answer. So we're big advocates of using the right tool for the job, and so timber has a number of amazing attributes that can be exploited, but it needs to be done in a way that leverages all of the benefits of timber. A concrete building and a timber building are going to have different spatial outcomes, and so being cognizant of that in the way that we're selecting materials is very useful. Once we've done that, then there's some more basic things that we can play around with, obvious things like grid optimizations. They can have significant impacts, again, around the level of sustainability within our design. Again, people frequently overspecify grids, commercial grids. We can see, 16 by 10 meter grids be specified pretty consistently. And then you might see, meeting rooms or offices located through. So you're specifying benefit that you don't really need. Once you've done all of those steps, well, then you have the choice to start to look at, maybe low carbon material specification. I think it should be a choice and an additional benefit rather than forgetting about all of the basic design things that we should be doing right as an industry, and then trying to make up for that approach, with a silver bullet and a high performing material. The other aspect which is key to sort of driving the level of embodied carbon within our buildings lower is around education. And, TTW, like a lot of other consultancies, sort of leveraging ourselves into trying to actually measure and monitor the level of embodied carbon across all of our projects. It's important because if we're able to visually display the impact of design decisions throughout the evolution of a project, then we'll start to actually inform behaviours that people will intuitively drive towards lower carbon designs. So we push, data-driven decision making. We then utilize that data to allow ourselves to critique our projects. We can benchmark against the other jobs that we have internally, and we can also then test alternate systems, grids, etc., in real time. So it's something that we're really pleased that the industry seems to be doing pretty consistently across the board. And so we think that this education piece will go a long way to starting to drive some of those behaviours in the right direction. And, it will naturally then put sustainable products like mass timber on a bit of a pedestal. So sort of any questions on that component before I jump into design challenges? You're all very quiet. Yes. Alistair?
Yeah, just a quick question, just on the data that you're using, just a couple of slides back when you were doing the comparison of the different materials and their systems. Are you using process-based DPD and LCA type data, or are you using input-output and hybrid type data to get your values?
So I asked my sustainability team that this morning. I believe the bulk of that data is EPD based.
Okay, thanks. Yeah, I mean, some of the numbers were a lot closer than I was expecting, so it'd be good just to sort of confirm that or check that later.
Yeah, absolutely. What I can do is I will link back to our internal team, and then we can provide a little bit more information around that. But it's a little bit of an aggregation, I believe. Some of our data will come from like Transport for New South Wales. They have pretty coherent information, and then where it's not relevant, particularly around things like mass timber, then I believe they try and utilise general EPD information. Yeah. Hamid?
Yes, Kevin. Look, I have a quick question about those comparison you made between different structural systems. Well, would you be able to tell us what was like the number of stories? Because I believe the height would be a big factor in terms of how each one of these numbers are coming out of the calculations you have for the emitted carbon.
They absolutely will. Obviously, the column size will be impacted pretty directly, but you obviously on very tall structures, you also gain floor stiffness advantages through larger columns as well. I will double check, but I would suggest that they're actually just looking at the horizontal component of the element,
right.
because it would need to be, you know, a like for like.
Okay, and I'm just curious to know whether you have also done any cost analysis on each and every one of these alternatives, because that was something I believe one of the subgroups, I believe the last one, the ones on financials, would be interested to look into possibly, and yet I believe it's a big factor, you know, to adopting timber or some sort of timber composite versus other structural systems or construction materials.
Yeah, we're pretty consistently asked around cost. We're sort of slightly apprehensive to do that given the industry of QSs in that space. But the challenge with cost is that if you, and we touch on it a little bit later, like if you're purely just looking at the materiality of it, you're not doing a product like timber anything like the justice it deserves, because you're limiting it to, you know, structure for structure, whereas timber has program benefits, it has follow-on trade benefits. There's a whole lot of other things that need to be looked at holistically as well. But you know, structure for structure, the work we've done, I think we're seeing generally it's a sort of slight price premium if you're looking at a timber structure over a concrete one of around about 10%. Obviously, they're all different given the demand and requirements, but that's if you're only looking at structure for structure, and I think it's the holistic argument, which is the one that systems like timber need to make, in my view.
Okay.
Jeremy?
Yeah, hi guys. Just one thing, when we did some studies in the past looking at embodied carbons and manufacturing carbons and things, we noticed there was a significant difference between some of the suppliers for various reasons, being whether or not they're using green electricity to run their mills, or they've got less intensive milling processes, or whatever it may be. And that had quite a significant impact on the overall embodied carbon results. So I'm not sure where you're drawing your data from, but other than to say it is very dependent on the supplier that we're using.
I completely agree. Like, I think, you know, you can change. I mean, you need obviously to run through for a period of time for your EPD to actually acknowledge that you're using greener energy. But we've seen some suppliers realize that their power is contributing negatively to the EPD, and I mean, it's a phone call to change that supply. So yeah, that has a big impact. So I should have probably prefaced this with these are pretty generic, and what we're using them for is apples with apples comparisons. Obviously, a real number will be dependent on where the concrete's coming from or where the timber is coming from, and so that is important from supplier to supplier in all materials. Sorry, there's some more questions. Can't actually see your name.
Jeremy Church, go for it.
Yep. Thanks, Kevin.
Hey, Jeremy.
I'm just interested to know, with the concrete comparisons that are drawn there, do they take into account things like formwork and that sort of thing, or are they purely looking at the finished output?
I believe they would take into account formwork. The thing with formwork is it's pretty heavily reused, so it wouldn't have quite as significant an impact. Obviously, if you were using permanent formwork like Bond-Lateral, that would change the scenario slightly.
Okay. Thank you.
Carl?
Yeah. Hi, everybody. It's a very interesting discussion, and it shows actually, it points really the finger to one of the key issues. So once we're presenting numbers, we have to make sure There's transparency about what the source and which methodologies we're referring to, because if I look through 26 presentations on the same subject, I get to 26 different results and outcomes. So that's an important one. The other one, Jeremy Church just asked about the formwork, is again, to what level of detail do we assess? Reusing formwork on its own is probably only one aspect, but that formwork needs to be transported, that formwork needs to be cleaned, etc. So there are kind of so many different levels which need to be considered once we kind of look into these kind of numbers. So I just want to encourage everybody, saying this is probably one of the focal points of the MECLA meeting and the work stream. So I think we have to take a really deep dive on that and get to a common understanding and a common way to not only communicate the numbers, but communicate that with competency and certainty.
Mm.
I think just on that point as well, when we're considering our mass timber structures, if we're going into that level of refinement, we should be really looking at the efficiency of the timber floor plate in terms of the number of screws and steel straps and plates that go into a lot of this, because I know a lot of comparisons broadly are just looking at like the timber volume itself, but when you walk around on site for some of these mass timber projects and you look at all of the steel brackets and the boxes and boxes of screws just sitting there, you're quickly throwing lots of little bits of carbon back into the building, which is perhaps not captured in quite a lot of the analysis that's done.
Yeah, it's a great point. Paolo? Paolo, you had a question? No?
Muted, Paolo.
Paolo, we can't hear you. All right, Hamid, go for it.
Sorry, I just have one comment following the questions and comments from Kyle, which was really great. I'm just thinking whether possibly that could be one of the outcome of this research or working group, let's say, to come up with a comprehensive list and then circulate it around, get everyone's to put bits and pieces into that list. And at the end, hopefully we have something which encompasses every component that should be considered for, let's say, a proper, reasonably accurate, if not saying completely accurate, let's say, estimation of the carbon credentials or emissions of different structural systems, especially with the focus on timber, like what Alexis said, screws, straps might be taken into account again. In concrete, we have formworks, in formwork, we have transport, cleanings, and there are so many layers that we should consider to do the justice, I would say, if you want a fair comparison between the system. And hopefully at the end, I presume timber will come up on the top because I'm a bit biased, but that's something I could be possibly considered as one of the outcome. I'm not sure whether we can continue this discussion or conversation later, offline later, or something, out there for all the group members to contribute and come into some sort of agreement for that one. Sorry, just some comments.
No, absolutely agree. Absolutely agree, Hamid. I was thinking the same thing. I mean, I think it'd be great to have a bit of a sheet on the subgroup folder links, which we'll set up post today, and it almost becomes a bit of a brain dump that everybody puts down exactly what all these sort of, detailed issues are, which come back to ultimately the impact on carbon. Paolo, can you speak? I think you got something wrong with your yeah, I can't unmute you. Sorry. Ken, over to you.
Thanks, y'all. And yeah, I appreciate y'all putting forth an idea of, a shared sheet. It's just, Hamid, just responding to something that I heard a bit. I was like, oh, we need to take into consideration like the straps and the screws and all this other kind of stuff. My quick response to that as like an LCA practitioner is that we don't have to really worry about that at this point in time. It's quite insignificant in terms of like the overall kind of thing. So if we're like later on, potentially, but I think if we're trying to get our heads around some things, like it's potentially not beneficial to really drill down that in that much detail, because the big impact, if we're thinking about carbon, is going to be, manufacturing, raw resource extraction, more than anything else, in terms of what's that carbon coefficient per square meter. So I know, I also have an architecture background, so I know how designers, we like to really drill down into the detail of kind of things. But in this kind of space, I think we need to make sure that we're keeping it simple, stupid, even if it is a complex kind of thing, as much as we can. So sometimes conflating these kind of things with like super detailed stuff can really start to people being like, it's too hard. So if we can kind of try to keep that in mind on how we want to steer what sorts of resources we develop, or even I guess like educational material. We talked about supply chain and also financing. Those kind of things will come into how do we actually articulate, how do we include timber into projects, not just from a design standpoint, but also so wider stakeholders, whether it's financiers, project managers, can quickly get their head around this. Sorry, I just wanted to add that really quick.
Yeah, no, thank you, Ken. Look, I'll just take one more from Simon, and then I think we should just press on. Simon?
Oh, look, thanks, everyone. Look, really fascinating discussion. Just want to touch on one thing you said about certain structures or certain systems being over-designed. I think that is a really valid point. And my question is, maybe coming out of this, is there any opportunity for a review of AS 1170, our loading code? Deflection limitations, point loads, UDLs, they haven't been looked at, I think, probably in about 40 years. And I'm just wondering whether there's opportunities there to make that more efficient. And in doing that, obviously, there's cost reductions, but also embodied energy and carbon reductions. And that could be a nice little piece of work for Standards Australia.
Yeah, look, I mean, I think from a prescriptive 1170 standpoint, that could potentially be done. I guess that would be a body of work that would need to push through, reliability and a whole lot of other of the fundamentals that underpin the code. But
absolutely,
if I think from some of the things that are even easier to do without challenging that, I mean, if you think of a commercial office building from the 60s and one now, they've got a very different amount of stuff in them, and we still design largely for similar levels of loading because that's what people are used to.
Steel shapes, absolutely.
And so it's the specification, I think, in many instances that, everyone's just trying to compete with the Joneses next door and out-specify in terms of what their particular asset can do. And, we're yet to see a building that is, globally limited by its STL requirement. Might have a local challenge here or there that can be addressed. But if you're applying these pretty onerous requirements across entire structures, well, then the proportion of savings is quite large. I think the other one is design life. So if you think of very, very big structures, they're generally going to be around for a lot longer than 50 years. Like, there's not many tall buildings in the world that have been demolished over 150 meters, and yet the cost to design them for a slightly longer design life is very small. But being able to demonstrate those values is quite big, particularly around when we're trying to, compare with a 50-year design life project. So the specification of what we're asking the buildings to do, I think, is also something that could be utilised before even you were to attack the code.
I think just to jump onto the back of Kevin's point about the specification of buildings, so that's an exercise that we're currently undertaking with Schools Infrastructure New South Wales. So we're working with them, looking at their EFSG, the guidelines and all of their structures to build against, and we've highlighted things that are quite onerous that could be addressed, and deflection limits that have worked their way in over time that nobody can explain where they've come from. So we've kind of like
Absolutely.
working with them to sort of peel that back, so things aren't built like bomb shelters every time, but also at the same point, like highlighted areas where they might have been lacking, and it's led to issues on structures as well. But overall, we're looking to make sure that what they're getting at the end is fit for purpose, but not so fit for purpose you could have a dance hall on every single floor.
Yeah, I mean, a good example at schools is libraries. Like, libraries don't have very many books in them anymore, but they're still designed for the same requirement as they used to be.
Yeah.
Um,
All right, I'll just press on, Kevin, if you're okay. Paolo, if you can unlock your mute, go for the question, but we'll proceed.
Right. Okay. So what I was going to talk about now were some of the challenges that we work through around timber design, and good to know more. Oh, I have to expand on that in a second. What we'll talk about is some of the challenges we see around, getting our timber projects across the line, because there's a range of perceptions more than reality that we battle on every project that we work through. So Alex and I will sort of talk through a few of these key points, and again, some of the steps that we take from procurement, but then you can also see how they might tie into some of those earlier conversations around things like grids or general efficiency. I guess
Kevin, sorry, just remind me, are you going to touch on end of use and reuse, recyclability? I can't remember.
I very briefly mentioned it at the start, but
okay,
no, it was more A1 to A3, because I think we've got to get that right before we then push into the reuse component, in my view. But I'm happy to talk generally about it if people are interested.
Yeah, when we get toward the end, we'll just have a look at Paolo's question that he put up on the chat.
Okay, awesome.
Done.
Do you want to give a little overview here?
Yeah, so I guess from a supply chain perspective, I guess we're more broadly talking here about CLT and large cross-section glulam, so all of the mass timber structures. But within Australia, there's XLAM Australia that have been established for quite a while now. In the last couple of years, CUSP down in Tasmania have popped up, but they're a more boutique-y CLT supplier that produce hardwood CLT panels. And I've noticed that Jeremy's on the call, so he can probably confirm the timeline for this. But I believe this year, Next Timber will be operational from a CLT and glulam production capacity, a high volume capacity over in South Australia. And then from the glulam space, well, within Australia, we've got Hine Timber. It's a thumbs up from Jeremy, so it looks like they're all good.
Yeah.
So Hine Timber, largely from Queensland, but down in Victoria, we've also got Australian sustainable hardwood. But what we are finding on quite a lot of our mass timber projects, from a supply chain perspective, it's opened up to a global supply. We've worked with, I think, most of these suppliers listed here at the moment, but there's a plethora of CLT suppliers, all with their own CLT panel build up, with their own little nuances on how they actually perform. But one of the things that we try to do in all of our design, sort of, up to tender stage, is actually design quite agnostically to allow for a different substitution of a different panel, whether it's, an Australian supply or a European supply. And then beyond that, appointment or, supplier actually engaged for the project, then we will work with that supplier based on what they can provide to then optimize the design. That way we're trying to have the most efficient structure for everybody.
Yeah, I think to sort of further that point, like it's something that, there's a lot of industry people on the call, but when we see our role as designers is not to fine tune a tender design for a specific manufacturer or client. What we're really trying to do is we're trying to create as much tension in the market with our design that is going to maximize the opportunity for the client to sort of get the best price and outcome for their project. And so we intentionally try and design in such a way that as many options are followed. If we lock in too early, we can sometimes find that the client may, lose a potential cost saving or an opportunity that they might have otherwise missed. There's some key differences, obviously, between local and internationally sourced timber, particularly around some of the shipping requirements and the opportunities that are created by local procurement and larger panel sizes, and obviously shorter transport and procurement times. And then there's some potential volume benefits from European suppliers, but you've got to containerize it and bring it halfway around the world. So what we're trying to do is make sure that our designs are efficient. Firstly, they tick the sort of the cost, the economy, the sustainability aspect, but then we're also trying to make sure that there's going to be a number of people who are going to competitively price them. And look, we'll touch, very briefly, grid is then tied intuitively both into shipping and procurement, and also sustainability. So, generally speaking, bigger grids are going to be slightly more expensive. Sort of sweet spot we're still yet to really beat on mass timber commercial is that sort of 6x9 type grid. It works fantastically from a containerization standpoint, and it's pretty good from a piece count on site, and it's still a relatively low volume. We'll give an example of a sort of 8.4 structure, which, holistically, when we look across a whole building with car parks, has its own benefits. Volumetrically, it's quite efficient, but it has some reasonable piece counts. And then the one on the right is when we're trying to still compete in a commercial market with other materials, and that's a slightly trickier one. We're having to start to substitute out some of the timber elements to try and get the spans, because the floor to floors on long spanning structures, particularly with mass timber, start to get challenged. We find once you go beyond 12 meters, it really starts to have a lot of volume of material to actually achieve those spans and control deflection. So what we try and do is we try and look at all of the alternatives. As Alex said, we're agnostic of supplier and things, but we also try and use the best material for the job as well. So if it's a long spanning type solution, or we use the timber where it's most effective, and we use another material where it's most effective. So we see that using a material to its strength is always going to be better than trying to shoehorn it into something that it's not. Some of the technical issues, and these tie into a huge amount around efficiency of buildings, things like service reticulation. When we're laying out a building grid, we're thinking about how we're going to reticulate the services. Timber, like any other material, you have the cost of the actual wood, and then it's all of the things that you do to it incrementally drive the cost up higher. So if you can avoid doing work through penetrations and stiffening and notches, that's all going to drive your economy from a cost perspective and also from a sustainability perspective down. So, little things like short grids coming out of the core to allow us to reticulate ductwork under beams are little tricks that we utilize to try and gain economy. I think you can see here, you can't see my cursor. Nice, you can. A short grid is a great tool set for timber to actually allow for that reticulation without all of these large penetrations.
Jeremy's got a question there, mate.
Jeremy.
It was really just an additional comment to what you're saying there, Kevin, particularly with service reticulation. From a detailing point of view, there's a lot of time and effort that goes into coordinating those penetrations, which can add time to the shop detailing process. So if we can avoid penetrations, then they can certainly be of program benefit as well.
I think just to add further to that one as well. So, you know, we spend quite a lot of time the tender stage of the project coordinating with the architect and all of the services consultants to get penetrations in the right spot, and we're, you know, trying to beat them into submission into, you know, reducing the size of their ducts, and then the tender packages get let, and a different you know, services consultant comes in to do each of their next set of disciplines or the next trades, and they've got a different thought on the strategy of, you know, how the services will work through the building. Sometimes they can't even get the I guess the original duct size or things to work, and then you have to go through and do that whole coordination process again. So I'm quite a big advocate of trying to detail into the structure some nice clear corridors for the services to run that just gives them completely free reign of doing whatever they want through there without impacting really the program and costs for the whole project.
And if you think about Paolo's comments or queries around circularity, like rather than specifically penetrating a beam for, you know, a services design, if you can avoid that, you obviously save the work and the cost associated. But maybe that's a much more flexible way to add circularity in the longer term. I mean, a beam with no holes in it can be transferred to another building and with a lot more simplicity than something that is so highly customized for a particular idea. Now, I know that's going to be a lot further down the path, but I think those sorts of themes need to come in more and more in terms of, you know, us designing buildings as kits of parts, or what do they say, like a temporary storage place for materials.
And dare I add something before I let Jeremy have a question, but dare I say that, you know, ultimately with timber beams and things, it'd be great not to have to do any of this for services, right? Because every time you're cutting a hole or a notch or whatever, what are you doing with that piece of timber? Where's it going? From the carbon argument point of view. Anyway, over to Jeremy.
I think it's a great philosophy to design services in runs where we don't need to coordinate with structure. It's a great philosophy to follow. I haven't yet been on one project where we haven't penetrated beams or added penetrations well beyond the AFC design. And that's because tenants, developers, clients in general want flexibility in their buildings. They want to be able to change things at the last minute. They'll have tenants, or depending on the type of building, be it retail, be it educational, be it commercial, whatever. It's a great philosophy, but one thing we get struck down on, and it comes up for every builder's headache, is when we go to get the final design endorsed by the powers to be the client or whoever, they always want to add more. And if we design a building which can't, with shallow beams which can't take any more penetrations, then they either have a compromised building, and they feel badly about adopting timber in the first place, or they get us to go back to the drawing board. So I think it's a great philosophy. At the same token, that philosophy has a lot of hairs on it based on the experiences we're having at the moment and in the past.
And I agree with you, Jeremy. I think that the thing that we might need to challenge on the buildings that we're looking at today is probably the floor-to-floor heights that we're needing to design to. So if we can design in, you know, clear zones where services can run wherever they want underneath the primary structure, or we, you know, do have these corridors that are completely clear for the services to run, I think that's a much better approach.
And or having them above the floor and having an access floor which allows for that, which is difficult. Or you know, this floor to floors are a hard one because often we're restricted in our floor heights and we feel that we're sacrificing floors because of services. And so hence you start off with all these good ideas of how we're going to make it work, and then cost planners get involved and everyone else gets involved, and it gets dumbed down and you're back to square one again.
Look, guys, sorry, we've got 3 minutes left. this is great conversation and very rigorous and detailed, and I think it's all valid for the subgroup content as well. So, Kevin, do you want to just get to a point where you're happy with yeah, last few slides?
Well, why don't I jump to you know, a real life project and get maybe Alex to quickly talk you through that.
Sure.
I'll issue the slides across to everyone anyway, and we're obviously very happy to speak to anyone, or even, you know, have another session at another time if anyone's interested anyway.
Yeah, if you could just issue it to myself, I'll put it up onto our webpage. That'd be great. Yeah, Alex.
Yeah, just very conscious of the time, so I'll fly through this one. But the Bond is a project that I've been working on for the last 4.5 years, and delivered throughout a lot of challenging times that we all know, like COVID. So the project went on hold, and there were supply chain issues, and even when things came back online, it was quite difficult to get trades out on site to complete things. But I'm happy to say last week I went to the opening ceremony of the project, so it's done. I can forget about it now. But quite a few lessons learned from this. But more like broadly, it's a 6-story office building, but there's 4 stories of concrete structure below. And we do have a bit of childcare services sort of mixed into the structural design, and also some 9A medical facilities as well. There's an oncology bunker within the basement, and one of the timber floors had an IVF clinic. So considerations there with mass timber for the floor vibration. But I think these are the few things that were touched on previously, but challenges for the projects were an 8.4 by 8.4 column grid. And a driver for that was there's quite a lot of car parking below, and we wanted to try and avoid transfer structures as much as possible, therefore using less material. But one of the key things here was the 3.7 meter floor to floor height was a real challenge for this project with the column grid that we needed to adopt. I think also mixing into that, one of the challenges that comes into play is the 2.7 meters clear that everybody's trying to achieve from the underside of the structure or the ceiling zone from the finished floor level. So maybe that's something that should be also challenged on projects moving forward. Just a couple of photos of the project throughout the construction. So all of these timber structures need some level of propping throughout as well. So, you know, maybe longer term thinking about carbon material and reuse, that's something that should be considered as well. But very, very slow project once, I guess, for all the elements within the ground and the concrete. But once we got up from the concrete podium to the timber, the floor cycle was 9 days for a 16,000 square meter floor plate. So quite quick. The project as a whole is about 84 meters long, stabilized by 2 concrete cores in the center that were constructed out of AFS, and then 2 bays of feature bracing on either end of the structure that were made out of glulam. And you can sort of see here on this floor plan that the front edge of the facade is angled, and you sort of end up with 2 pinch points at either end of the building where you've got quite acute angles coming into one particular column. Sort of a little bit architecturally driven, the bracing strategy for this project, but they were wanting to do something a little bit different than the chevron type bracing that you see on most mass timber projects. I think we worked quite hard to get this to work, but, you know, reflecting on what we worked through from a material and efficiency perspective, this is probably not the best response, because you end up using quite a lot of steel in these brackets and these connections to hold everything together. So if I think I had my time again, I'd probably use the carbon argument to help persuade the architects away from a response like this. So I spent quite a lot of time working through surface reticulation for the structure and designing in notches and penetrations for the tender surfaces set, and ultimately not all of those notches and not all of those penetrations were used, which is a little bit frustrating and disappointing. Just a couple of examples of what those look like on site. I don't think I've got any in here of what the finished product looks like. But this is one of the things that we work through on the bond, is designed a fairly agnostic tender set of documentation. And once Binderholz, so an Austrian supplier, were brought onto the project, we worked with them to refine the timber design based on what their actual supply chain was. But one of the things that really unlocked a bit of volume for the project was an allowable change in depth of the secondary beams. So as we were working through the project, we were quite limited to the depth that we were allowed of the secondary beam at 560 mil. But it's amazing what you can sort of challenge further down the project when there are dollars involved. So once the builder was appointed, once the timber supplier was appointed, and we could demonstrate that through using a deeper secondary beam, the architect was then actually, and the client was actually able to yield on the structural depths that we needed to work to, which helped unlock more efficiency for the structure.